Hello everybody, my name's Matt. In today's video we're gonna build a simple C server from scratch. In this video we are only going to use system libraries, no frameworks, no external dependencies, just pure Linux system calls. We will also learn how the internet actually works under the hood. Sockets, TCP, connections, and HTTP responses. Before we start, let's make sure everything's installed. First, you need a Linux system. If you don't have one, you can use WSL on Windows, or you can just install Linux on a virtual machine, or use it on your home PC like I do. I use NixOS, but you can use everything else you want, like Ubuntu or Arch or anything else. It does not matter, but you do need the Linux kernel to do the Linux system calls. You could use Docker if you want to, but if you can use Docker, you can also just install Linux. It's mostly more easy and more convenient, so just do this. Then, if you have this, you need a software that is called GNU Compiler Collection. The GNU Compiler Collection, also known as GCC, is our compiler for C right now. So we use GCC. And if you just use GCC like this, it will give you an error. It just says a fatal error because there's no input file. And you need an input file like, as example, I don't know, your main.c, and then you can compile your main.c with some arguments like -o and then give it the executable name. But that's for later. We don't do this right now. But you need to have the GCC compiler, so maybe you need to install it, or maybe you have it right now. On a nixconfig file, it's just GCC to install. You can install it like everywhere, and it is probably installed on your system currently, hopefully. You can use another C compiler if you want, but I highly recommend using GCC. So this is everything you need to have for this tutorial. There are no other requirements. We are only using system calls right now. So at first we create our working directory. We do this with make directory and then the directory name. Let's call it YouTube. And we press enter and we created a directory called YouTube. And then we do cd YouTube and go to this directory. And if you do ls now, you see there's one file, the C file we created right now. And you can edit it with whatever you like. You can use something like Vim, but you can also use a normal IDE like Visual Studio Code or whatever you like. I'm going to use the editor nano for this tutorial, so we're gonna say nano main.c, add up in nano. It does look a bit off for most normal Windows user or normal people. This is just a thing I can use in the command line. That is for me the easiest way to show you, but you can use the normal IDE. Normally I only want to use this because it's the most simple for me, and it shows that you don't need anything fancy to start programming. You only need something like a command line in Windows and something like nano. You can use the addr command on Windows if you want to, or Visual Studio Code if you want an IDE or C line or anything like that, or whatever you want. So, and now we're actually writing our code. We do the imports for now. So I'm gonna do the imports in C. We do it with include, and then we're gonna do sys/socket.h. Socket is the thing with we can do networks connections. So we can do a network socket, that's a network connection, with the module socket. Then we include another thing. We include net inet/in.h that we can use for our internet address structure with our IPv4 address and that stuff. We come to it later. And we include UNI standard.h. This thing is for read, write, and close. So if you say read, write, or close, you actually gonna call UNI standard.h. Yeah. Now we include and call it string.h. That's our normal string thing. We can do things like this thing, string length. That's the string length. We need this for parsing in a few ways, so we do need this. And we do say include standard.io.h for things like print f. That's everything we need for the Linux system header that gives us access to networking and basic I/O. Now we create our main function. We do this like in every C program with int main and then these brackets, and here's our C program. So every C program does start this function main when it's executed. So that's the beginning of everything. Now we create our socket. We call our socket server underscore fd, and we're gonna set it equal to socket, and then like this. But there are arguments we need to do into this function 3, and that's first af underscore inet. This is our IP version 4 networking thing, so we got this thing from this thing here. And then we do need 2 other things. That's the socket underscore stream, what just is our TCP connection. And we say 0. Why 0? Because we just let our system choose the protocol we use automatically. So we could say a protocol here, but I'm just gonna say 0, and then the system does decide what it wants to use by its own. Then we create another thing, the server address. So we're gonna say, now we create our struct, that is, if you want to say that like that, a container for variables. Then we use socket, yeah, I'm stupid, sorry, sockaddr underscore in, and then our name, we call it addr, and this is our container for variables. Sockaddr in is again from our internet connection with IP version 4, and addr is just our name. Yeah. Then we're gonna do a few other things. We say addr.syn underscore family is equal to af underscore inet. This again is from netinet. You see the inet is still there. So yeah, and we're gonna do 2 other things with our addr right now. We do addr.syn underscore addr.s underscore addr. and we equal to inaddr underscore any, and this addr.sin underscore addr.s underscore addr is equal to inner addr underscore any. Does just mean that it listens to all network interfaces that are currently running right now, and we're gonna say addr.sin underscore port, and gonna say some port. I'm gonna use for this tutorial 8080. That's a standard port for me that's open and that I can use, but you can use anything else on your system that is open. I do 8080, yeah. And then we gonna do something else. We gonna bind the socket. So we say bind, pretty self-explanatory that we can use bind here. And we do a few other things here. We do server underscore fd here. That's the thing we created here. This is our variable server fd. That is our socket. So we're gonna add our socket here. We gonna say that we do struct sockaddr star, and then we gonna do an and addr, and then we say sizeof, and then we say addr, and I need to think real quick. That are enough. Yeah, that are enough, like this. And that does just mean that we connect to the socket to our ports. Then we do the listen part, pretty simple with listen. And we just say server underscore fd and say something like 5. And then we know that the server is waiting for incoming connections all the time, so it just waits and listens till it finds a connection. We need a server loop, so I'm gonna say, just for debugging purpose, printf, and we're gonna say server is running on HTTP, not HTTPS. That's not a secure web server. -- local host, and then our port. In my case, it's 8080, but it could be something else in your case. And then new line, and that's it. Then we're gonna do our while, so that it does do it all the time and not just when I start the script, because that's not what a web server should do. While 1, because it should run all the time. And then we need another braces here. Int client here. Client is our client that connects to the website, and we say accept, because we want to accept the request. Server underscore fd. And now that the browser can connect to our server, and then we say char buffer #24, like this. That's our buffer. Then we say int r is equal to read client, because we want to read the client, the buffer, and size of buffer, to get the size of the buffer, -1. And then we say buffer r, and here we say this and 0. Don't forget the semicolon. Oh, of course, you should not forget the semicolon, because this will give you an error everywhere in the code. Doesn't matter where exactly, but I guess I forgot it a few times. Not that often, okay. But you should not forget it. It's just plain C code, so there you need to do that in every line, except for like while and that stuff. But you should know that, or if you don't, it's not bad, but you don't need to know it. But just everywhere a semicolon after each line. I'm gonna do for our lovely debugging purposes printf again. I'm gonna say in this way request, sorry, and then we're gonna say, I would say new line a bit, and then dash s, and then again new line. Yeah, that looks good. And then we say we do the buffer init, and we got our debugging print. Now we're going on to actually do the response to our client in HTML. We can do it in plain, but we do it in HTML now. We do it with char, then star, then response. I call it response now. And then we do an equal sign, and then we can go into another line and say http dash 1.1 200 okay, and then we say rn, and this tells the browser, yo, your request is okay, it was correctly, like we can use it. Then we say what content we actually have, so we say content minus type. You can say text and then plain text, but I will use HTML for now because that's what most people want to see on their websites. Then we gonna do rn, and we're gonna do the actual HTML. That means we say HTML. Then we say body, like this, and then we do a header, I would say. So we say h1 for a header, and then we say hello from our, or from my C server. Yeah, you can do whatever you want here, and we close that again, and we say let's do a paragraph just to see that there's a difference. This is I don't know what it's called. This is a website. This is way better. And then we need to close our body and our HTML. So I say body and HTML. And that's it. We need our semicolon here. And then we send this response we wrote down here with write, and then we say client because we want to write it to our client, and we're gonna say response because that's what we want to write to our client, and then we say string length response because that's the length of the thing we want to write, the length of our string here. That's again why we need string for, because of string length. Without it would be a lot harder to do that. So we just use string length. It's easy and it's a syscall. We can use it. It's low level enough for us for now. And then we say close client, that we close our client to don't have like them waiting for it. And that is actually it. That's actually what we wanted. Then I save it. And then if I say cat main.c, it shows me the WUL file like I like it. You may wonder why my cat looks like this. This is because of my system. If you want to duplicate it, I can make a video on it. It's pretty cool actually. But yeah, that's my system. We going to test it out now. So I'm going to say gcc main.c-o main, enter. And we got an error. Look where the error is. Socket stream is not really there. What did I wrong? I guess I misspelled. It's not socket stream, it's sock stream. Sorry guys, that was not wanted from me, but it's sock stream. So we say sock stream, and we do it now. And addr is also why it's wrong. In code objects, not function or function pointer. Wait, what? Addr, it's in line 13. It's here. It should work like this, I guess. What did I wrong? I'm so stupid. Please don't copy from me. It's my first video, you know. It's obviously 80 ounce. I guess it was spelled 80. I guess it was spelled 80 ounce. I would say it is, and it is. And then if we now say main, we start our server. We got our cool print f message service running on this thing, and we look at this one, and we're gonna say curl, and then we say http local host 8080. We can also do, if we want to, something like another terminal, and say curl, and we get our HTTP response that looks like this HTML body. You also get here our request, what we actually are. We are a Mozilla 5.0 X11, many things you can see here. It's a lot. And curl thing looks like this, not that big. Browser thing looks like this, a bit bigger. So we say C, and we did it. And you did a C server from scratch. That's pretty amazing. But don't forget to like and subscribe.